Danger! In this video, I'll be producing ammonium hexachloroplatinate, a soluble salt of platinum that causes platinosis, an allergy-like reaction on the skin, eyes, or in the respiratory system. Platinosis symptoms may include asthma, dermatitis, dyspnea, conjunctival vasodilation, and rhinopharyngitis. Halogenal platinum compounds are among the most potent respiratory and skin sensitizers known. Platinosis symptoms may take months or years to appear. These symptoms are progressive, permanent, and incurable. So unless you want to spend the rest of your life with bleeding eyelids, a permanent cough with sore throat and runny nose, and your skin covered with large, flaky, crusty bumps, then do not try to repeat this experiment.
Hello YouTube, and welcome back to part 2 of this platinum refining video. I'd like to re-emphasize here, I'm not actually refining the metal, it's pure already. What I'm doing is going through and familiarizing myself with the process and all the steps that are involved to do a refining, because I've got some platinum group metal refining videos coming up in the future. I've got to get myself up to speed on what to do for these things, and this is my first time refining platinum. So I just want to make that clear, that this is a learning process for me, and you get to watch me learn as I go. Today what I'll do is, we've had the solution out there evaporating for 18 hours or so, and I want to evaporate it all the way down to a syrup, and then we'll be denoxing with some hydrochloric acid. Once we get all the nitric acid out of there, I'll go ahead and prepare a saturated solution of ammonium chloride, and we'll precipitate the hexachloroplatinate with the ammonium chloride, and then we'll filter it out in a filter, and then I'll transfer the hexachloroplatinate to a fused quartz dish, and then we'll burn off all the remaining ammonium chloride, and we'll leave pure platinum sponge. So that's what we're going to do today. Let's get to it. The solution has been evaporating on a hot water bath now for, well, since 7 p.m. and it is 1 p.m. The following day, so it's been on there 18 hours, and it looks like it's been reduced by about half, and we still got a little ways to go to get it all the way down to a syrup. I'm not going to rush this thing. I'm going to take our time and get it down to a nice syrup with that hot water bath, so we don't ruin this batch. The solution's evaporated down now to a syrup. It's about, oh, maybe 1/8 of the volume that it was when I started the evaporation. You can see it's been on quite a while, probably about a good 20 hours or so. I'll go ahead and take it off of there and put it into a beaker now. Now I'll transfer the solution from the boiling flask to the beaker, and I'm going to be rinsing it with hydrochloric acid as I go. Got it all out of there. Now I'll lower the beaker down into the dish, suspending it above the dish, not touching it. I'm going to fill it with water and continue to evaporate the solution.
I use hydrochloric acid to rinse down the inside of the beaker.
Okay, I've got the solution evaporated down to about 25 ml right now. I'm going to go ahead and cover it up. I'm going to turn the stir bar off, and I'm going to add some concentrated hydrochloric acid here and see if we can get some fumes to evolve. See if we still got any nitric acid in there.
If excess nitric acid is present, then brown fumes will be thrown off of the solution as the hydrochloric acid is added.
I don't really see anything. I'm going to try one more shot of hydrochloric acid in here and see if I can see any fumes coming off of this thing. If I don't, then I'm going to assume that all the nitric has been driven off. Looks clear as a bell in there. Looks like it's time to go ahead and set up for the precipitation with ammonium chloride.
If brown fumes had appeared, then further evaporation would have been required.
I've got some ammonium chloride here. I've got some hot water down here, about 75 ml in a beaker. We'll go ahead and dissolve some of this in there and make a concentrated solution, a saturated solution.
To ensure I have a saturated solution, I want a little bit of ammonium chloride left undissolved on the bottom of that beaker.
I'm going to take down the platinum solution here. Get the stir bar out.
I use a small magnet to lift the stir bar out of the solution up the side of the beaker.
I'm going to rinse all the color off of it. Grab it out of there with a pair of tweezers. Okay, I've got a saturated solution of ammonium chloride over here. I've got our platinum solution here. Both hot. I'm going to go ahead and add the ammonium chloride. I'm just going to pour it right in and see what happens here. Almost looks like a banana milkshake. And this is our pure platinum salt, hexachloroplatinate. What we'll do is wait for this to settle a little bit here and get it into a filter. The ammonium hexachloroplatinate has been allowed to settle overnight here, and I've got some crystallization of the ammonium chloride coming out, and on top of it there I'm going to try to get some of that to dissolve with using a 15% solution of ammonium chloride before I try to filter it off.
The yellow precipitate is soluble in water. That's why I use 15% ammonium chloride solution to dissolve those crystals.
The ammonium chloride crystals that had formed on top of the yellow platinum salt have been dissolved now. I added a little 15% ammonium chloride solution, and then that didn't quite do the trick, so I added just a few ml of distilled water. And I think the ammonium chloride crystals are gone now. We'll let this settle, and I can get this into a filter. I'll go ahead and put the platinum salt into a funnel here.
I changed the camera angle here to give a better view of how I use hydrochloric acid to rinse the hexachloroplatinate from the beaker. Hexachloroplatinate is not soluble in hydrochloric acid.
Got all the hexachloroplatinate into a filter funnel here. Just waiting for all the liquid to drain out. Once I get it all drained out, I'll go ahead and transfer this to a calcining dish, and we'll go ahead and put some heat on it and then drive off the ammonium chloride, get our pure platinum sponge.
In this shot, I use concentrated hydrochloric acid to rinse the yellow platinum salt down into a central mass in the filter.
I'm going to transfer the pure platinum salt to this fused quartz dish. I ordered this, I can't remember what the company name was, but it was they're expensive. I think 2 of them cost me $100. I'll start this by turning the heat on over here. I got a hot plate with a Corningware dish on it. Now I'm going to transfer the hexachloroplatinate from the funnel into this quartz dish. It'd be nice if it all came out in a nice little cake. Alright, this is the beaker that the yellow precipitate came out of. I'll go ahead and try to get the filter off of here now. Get the material down into the fused quartz dish, if it'll cooperate. Thankfully, I got most of the pure platinum salt into the fused quartz dish here. The remainder and the filter are going to go in this beaker. What I'll do is I'll dissolve that with aqua regia and add it to my stock pot. Okay, I got the heat set on medium-low on this burner. I'm going to go ahead and put the fused quartz dish with the hexachloroplatinate right in there. Start the burning process. I had the heat on medium-low, but I turned it down to low because I still got some liquid in there and I don't want this boiling and spattering. So I turned it down on low until I get most of that liquid evaporated off. Putting the yellow precipitate in that dish and put some heat on it with so much moisture in it there was probably a mistake. This is a learning process for me. I should have probably dried it out a little bit better before I committed to burning off the ammonium chloride, but like I said, it's a learning process. I got it on way low heat right here. I'll just let it evaporate until it dries out a little bit, and then I'll start turning the heat up. I learned two important things here. Number one is to don't preheat that plate back there before I put the material on to burn it. And number two is to wait until a lot more of the moisture has dropped out of that cake of material in the filter before I try to put it in that fused quartz dish. Again, I'd like to point out that this is a practice refining so that I can get familiar with the procedures of doing this. This is my first time doing it, and I'm learning a lot, and hopefully you're learning too. As a safety note, it's important to point out that it's not a good idea to dry the salt out. If it's dried out, it can become powder and airborne, and then it has a chance to get into lungs and get inhaled, and that would be a very bad thing, as this stuff is highly toxic. So, on with the process. I bumped the heat up here from just below the low setting on the burner to just above the low setting on the burner, so that we can go ahead and dry some of the moisture out of that material in the fused quartz dish. The platinum salt has been on the burner there now for quite a good while. It's pretty much got it dried out, and it's starting to burn now. I can see a little bit of white smoke coming off of it. I've got the heat turned up on high, and we're going to go ahead and keep an eye on it here, see if we can notice a difference as it burns off the ammonium chloride. I tried to calcine the platinum salt here, and couldn't get it hot enough in my fume hood here. So what I'm going to do is I'm going to transfer it into this graphite crucible and then put it in my electric melt pot. I've transferred all the half-baked hexachloroplatinate into a graphite crucible here. Go ahead and put this in the melt pot and turn it on. Let's see if we can get this stuff to burn in here. I'm going to say this has been properly calcined now. Turn this off. It only took about 10 minutes. I'm going to turn this off and let it cool down. We'll get the platinum out of there. This should be some pure platinum sponge. Platinum sponge looks real good down in there. Just cools off, get that out, weigh it, we'll be done with it. We've got the burnt platinum here in the graphite crucible. I'm going to go ahead and get a weight on it, and then we're going to take a look at what this stuff looks like. And we got 6.4 grams, it looks like. 6.4 grams. Platinum sponge, and here it is, our pure platinum sponge. Gray looking material. I'll hang on to this, and what I'll do is probably throw it in with the next batch of platinum that I try to refine. that concludes our experiment. Well, I think it's about 1 a.m., maybe 1:30, something like that. And I've been working on this experiment for 3 days. I'm wore out. It was very challenging. I enjoyed doing it, but I got to tell you, glad it's over. What we did was we took that pure platinum coin, we dissolved it in aqua regia, then we precipitated the platinum out of the solution with ammonium chloride, and then we tried to calcine it on the burner out there. I learned a valuable lesson there. The burner doesn't get hot enough, just plain and simple. When I put it in the graphite crucible and put it in my electric furnace, it was done in 10 minutes. If I'd have done that in the first place, I think we'd have been a lot better off. But anyway, I learned a lesson there. So that concludes the platinum refining experiment. We're on to new things now, and be watching for some more exciting videos about platinum group metal refining. Thanks and good night.